Okay, good morning my esteemed viewers out there. So if you are just tuning into my channel for the very first time, it's your favorite tutor, the formula. So without wasting further time now, we are just going to go to the business of the day. So looking at my board right here, you can see a question on the board. We were told to find the term independent of s and its coefficient in the expansion. If we were to expand this, which term we have no s? Which of these terms will contain no s? That is what the question is telling us. So let us see the term that will have no s if we were to expand something like this. So all we need to do is to come and just write solution. Let me share my board into two so that I can just conserve a little space. Now, when you expand this particular man on the board, this guy is going to give us a polynomial. And a polynomial is like a sequence. It will produce a sequence. So the last term of the sequence that this guy will form when it has been expanded is Tn is n combination arrow a raised to the power n minus arrow b raised to the power of arrow. Please note that n combination arrow is written symbolically like this, and it is n factorial arrow factorial into n minus arrow factorial. So please take note that n combination 0 is n combination n, and they are equal to 1. And from this particular expression on the board, it is obvious that n is 12, a is 2s squared, where b is minus 1 over s. That is what we are going to have. Now, without wasting further time, let us quickly insert all these values into this place and simplify. Please take note that n is still the same thing as arrow plus 1. So we can simply say that t arrow plus 1 is n is 12 combination arrow into a is 2s squared raised to the power 12 minus arrow into b, which is minus 1 over s raised to the power of what? Arrow. Now let us quickly explain. Remember that what we simply need here is the s. The s are what we need, so we can just go and say t arrow plus 1 is 12 combination arrow into, we can expand this guy. This man here can be written as 2 raised to the power 12 minus arrow into s squared raised to the power 12 minus arrow. Then this particular man here, we can write this guy as minus 1 raised to the power arrow into, this minus 1 is just, this 1 here can be written as minus 1. So we can say minus 1 raised to the power arrow. Then what is left is 1 over s. 1 over s will still raise to the power of arrow, but 1 over s can be written as s raised to the power minus arrow without wasting much time. So we are now going to have t arrow plus 1 is minus 1 raised to the power arrow. Let us bring numbers, all these numbers. Look at this number, bring it to this number, 2 raised to the power 12 minus arrow. Then I'll just call this guy into 12 combination arrow is times, sorry, this s and this s. Remember that s is what we are interested in getting. So all we need to do, these two s, they are multiplying each other, so, and they have power. We just add their powers according to the laws of indices. We are going to have 12 minus arrow, we add their power. For a term, let's continue from here. For a term to be independent of s, for a term to be independent of s, the power of that term, look at this term, we want everything here now to be 0. We want the power of s to be 0. The power of s here is 2 bracket 12 minus arrow minus arrow. So we want this power to be 0. So what do we do now? We just equate everything here as 0. So it becomes 2 bracket 12 minus arrow, let it equal to 0. So when I expand, we are going to have 24 minus 2 arrow minus arrow is 0. So 24 minus 3 arrow should be 0. When I collect like terms, we are going to have that 3 arrow is 24. And if 3 arrow is 24, if I divide it by 3 divided by 3, this into this, therefore arrow is 8. Now we have gotten arrow as 8. So since arrow is 8, all we need to do now is to start deducing. We start deducing our answer. We start bringing out our answer. So we are looking for two things. We are looking for the term that is independent of s and the number with that term, the coefficient of the term. So we just call that t arrow plus 1 is t8 plus 1, which is t9. So the term independent of s, t9 is independent of s. So t9 is independent of s. Now, what is the coefficient of t9? What is the number on t9? To get that coefficient now, all we simply need to do is to simplify from here to here. We just come minus 1 raised to power arrow, then 2 raised to power 12 minus arrow into 12 combination arrow. We just expand this guy. We simplify this man now for we to get the term that is what now independent of what s. So we just come now for we to get the coefficient rather. So this becomes minus 1 raised to the power 8 into 2 raised to the power 12 minus 8 is 4 into 12 combination arrow is what 8. So minus 1 raised to power, see, a negative number raised to power an even number. When a negative number is carrying an even number as a power, the sign changes. If the sign is plus, if the sign is minus before, sorry, it will just turn into what? Plus. So minus 1 raised to power 8 is what? Plus 1. 1 times this guy is going to give me 16 bracket 12 combination arrow. So T9 is 16 into 12 factorial. Expanding this guy, we are going to have 12 factorial into, remember that this guy is already what? 8. Please pardon me. We already have 8 then. 12 factorial, then 8 factorial. 12 minus 8 is 4 factorial. Now, let me quickly point this guy in my calculator for me to quickly have the answers I am looking for. Please pardon me. I just want to save my little time. So when you simplify this guy, we are going to have 7920. So our answer is 9,7920. So ladies and gentlemen, the ninth term is independent of s and the coefficient is what? 7920. So this is how I would like to call it a day in this class. I will see you in my next episode. Have a nice day.